Root finding in Python. Edit. A big issue here is that scipy.optimize.brent requires that the limits of the search interval have opposite sign. If you slice up your search interval into arbitrary sections and run brent on each section, as I do below and as Dan does in the comments, you wind up throwing a lot of useless value errors. Is there a slick way to deal with this in Python? Original post. I'm repeatedly searching functions for their largest zero in Python. Right now I'm using scipy.optimize.brent to look for a root, and then using a brutish search method if my initial bounds don't work. There are two big problems with this. First, I assume that if there are multiple roots in an interval, brent will return the largest. I did some simple testing, and I've never seen it return anything except the largest root, but I don't know if that's true in all cases. The second problem is that in the script I'm using, this function will always return 0 in certain cases, even though the function I pass to bigroot diverges at 0. If I change the step size of the search from 0.1 to 0.01, then it will return a constant non-zero value in those cases. I realize the details of that depend on the function I'm passing to bigroot, but I think the problem might be with the way I'm doing the search. The question is, what's a smarter way to look for the largest root of a function in Python? Thanks, Dan. A little more info is below as requested. The functions I'm searching are well behaved in the regions I'm interested in. An example is plotted below, code at the end of the post. The only singular point is at 0, the peak that goes off the top of the plot is finite, and there are either 2 or 3 roots. The largest root usually isn't greater than 1, but it never does anything like run away to infinity. The intervals between roots get smaller at the low end of the domain, but they'll never become extremely small. I'd say they'll always be larger than 10 to the power of -3.
Good question, but it's a math problem rather than a Python problem. In the absence of an analytic formula for the roots of a function, there's no way to guarantee that you found the largest root of that function, even on a given finite interval. For example, I can construct a function which oscillates between plus or minus 1 faster and faster as it approaches 1. This would balk any numerical method that tries to find the largest root on the interval 0, 1, since for any root there are always larger ones in the interval. So you'll have to give some background about the characteristics of the functions in question in order to get any more insight into this general problem. Update: looks like the functions are well behaved. The Brent doc suggests there is no guarantee of finding the largest/smallest root in the interval. Try partitioning the intervals and recursively searching for smaller and larger other roots. I tried this on your function and it finds the largest root at 0.14. There's something tricky about Brent, though. The sin function should have roots at 0, pi, 2 pi, 3 pi. But this approach is only finding the first 2. I realized that the problem is right there in the docs. F, A, and F, B must have opposite signs. It appears that all of the scipy.optimize root finding functions have the same requirement, so partitioning the intervals arbitrarily won't work.
If you want to support the channel, please consider liking and subscribing.